This video demonstrates the features and operating instructions for Siemens medium voltage GMSG OEM component product line. It serves as a high-level overview. For detailed instructions on the selection, operation, and maintenance of the equipment, please refer to the GMSG switchgear and GMSG circuit breaker instruction manuals, the OEM components catalog, or the switchgear selection and application guide. Let's begin by looking at the skeleton, which is offered in 3 basic configurations and in a variety of stacking options for your switchgear project. No matter which structure you implement, OEM partners need to design and add approximately 28 inches of structure for the terminal compartment, plus bus bars and front and rear doors. This vertical section can then be bolted to additional vertical sections side by side. End sections require side sheets. For the purpose of this video, we'll look at the C, D over B option. From top to bottom, you have the C compartment, the D compartment, the low voltage compartment, and the GMSG circuit breaker cell. Let's take a closer look at each. The GMSG circuit breaker cell is at the bottom of this skeleton and features a racking mechanism at the center of the cell. The drive block engages the GMSG circuit breaker when it's inserted. Letters on the racking mechanism indicate which position the circuit breaker is in. D means the circuit breaker and the mechanism are in the disconnect position. The other positions are T for test and C for connect. Whether you manually or electrically rack the circuit breaker, the position indicator must be visible through the door. These yellow and green bars line up with the front of the circuit breaker. As the circuit breaker is racked, this block connects with the circuit breaker and moves in and out of the cell. In order to see if these line up properly, you must look straight down from the top of the circuit breaker. Next to the racking mechanism is a sliding cam plate. It has a padlock provision, so up to 3 padlocks can be installed to prevent closing of the circuit breaker. This is the worm gear. It's important that this stays lubricated. If additional grease is required, please contact Siemens. Next, we have the interference blocking plate, or coding interlock, which prevents the incorrect size circuit breaker from being inserted into the cell. And to the right of that is the interference plate position, which is used as an option if special interlocking is needed for an electrically operated ground test device. When working around medium voltage equipment, it's critical that metal structures are grounded. On the left side of this cell is a ground bar. The bottom of the circuit breaker has a contact shoe that contacts with the ground as soon as you insert the circuit breaker into the cell. This is the secondary disconnect block. It has 16 contacts, which connect into the control circuitry and auxiliary interlocks on the circuit breaker. From this block, a wiring harness can be routed into the low voltage compartment. This equipment ground is used for grounding the controls and protective relays, as well as the switchgear structure. Running along the right and left side of this section are passageways for wiring. They go through the bottom and up into the auxiliary compartment. On the right side of this cell are the Mach and Tock assemblies. These are used in the controls and protection schemes for medium voltage switchgear. When the shutter is open, you'll see exposed bushings and primary disconnect stabs. You can also see the black current transformers, which are optional, mounted on the bottom. Next, let's discuss the most important element of the switchgear, the vacuum circuit breaker. When you receive your GMSG vacuum circuit breaker, always inspect the shipping container before removing or unpacking the unit. Check for shipping damage or rough handling by the carrier. Also, check each item against the packing list to identify any shortages. Accessories like the manual charging crank, the racking crank, and the split plug jumper ship separately. After you unpack the circuit breaker, please observe that it is normally shipped with primary contacts open and springs discharged. It's important to verify the discharged condition of the spring-loaded mechanism after de-energizing control power. We'll demonstrate this later in this video. Now, let's take a look at some of the features on the front panel. The label has important information related to the circuit breaker, like the breaker model number, serial number, rated voltage, interrupting capacity, continuous current rating, as well as the ratings for the trip coil, close coil, and motor. If you have any questions about the circuit breaker or experience any issues, email a photo of the label or provide the serial number of the circuit breaker along with your order information to a Siemens customer service representative. This is where the charging handle is connected to charge the closing springs in the circuit breaker. These are the push to close and push to trip buttons. Both are colored according to ANSI standards. On the left side of this panel is the spring charge status indicator, which is either charged or discharged. Here is the operations counter for the circuit breaker. Remember, Siemens medium voltage circuit breakers are tested in the factory, so it's normal for a brand new circuit breaker to show 250 to 300 operations on this counter. And finally, these handles help move the circuit breaker into and out of the cell. Now, let's take a look inside. We have the trip coil, the close coil, and open and close buttons. There are several limit switches that are internal parts to the circuit breaker control circuit. This electric charging motor connects to the main drive gearbox, which can be operated mechanically or electrically. These are the auxiliary switches, and this is the anti-pump or Y relay. This is the wiring harness which goes to the 16-pole disconnect. Let's take a look at the important components found on the bottom of the circuit breaker. This is the trip-free interlock. It prevents closing the circuit breaker unless the circuit breaker is in either the connected position or in the test position. The trip-free interlock interacts with the sliding cam plate on the racking mechanism. This is the closed circuit breaker interlock. It prevents access to the racking screw when the circuit breaker is closed. This is the guide rail. It helps align the circuit breaker in the compartment. Here we have the circuit breaker interference plate to help ensure an adequately rated circuit breaker is being inserted into the cell. The latch mechanism attaches to the drive block, which moves the circuit breaker as you rack it. To remove the circuit breaker, push down the latch release. The circuit breaker moves on the floor on these rugged polycarbonate wheels, secured by steel hardware. Note that there's another set of smaller metal wheels that connect with the rails as the circuit breaker is inserted into the cell. Let's charge the circuit breaker closing spring using the manual crank. Insert the crank and make sure it's engaged. Begin turning to start charging. You'll notice the indicator change as the springs become charged. Next, we're going to demonstrate the spring discharge check procedure. Perform the spring discharge check before removing the circuit breaker from the pallet or switchgear. The spring discharge check should be performed after de-energizing control power. This check assures both the tripping and closing springs are fully discharged. Open the circuit breaker and rack to the disconnect position, and then perform the spring discharge check. Press the red trip push button, and then press the black close push button. Press the red trip push button again. Verify the spring condition indicator shows discharged, and then verify that the main contact status indicator shows open. In order to rack a circuit breaker or VT tray as shown, or circuit breaker in and out of an upper cell or switchgear mounted on a pad, GMSG extension rails need to be inserted. One important safety feature of the rails is their shape. The rails have a notch in them. You can feel the notch engage when it's inserted. To be sure the notch is engaged, try to pull the rail out. Siemens GMSG switchgear also features a low-voltage auxiliary compartment. The auxiliary compartment has removable white interior mounting plates. The white finish makes it easy for installation and service personnel to locate wires. Fuse blocks, terminal blocks, interposing relays, auxiliary relays, and other devices can be mounted to these panels. You'll notice there are two labels on this compartment. The rating label describes the type and configuration of the compartment and the ratings of that particular GMSG skeleton section. The second label is the UR Component Recognition label. It details what section of the equipment was manufactured in the Siemens factory, so the rest of the equipment from our OEM partner can be certified. When feeding wires in and out of the low voltage compartment, you'll notice the spaces are lined with edge protectors. This prevents the sharp metal edges from destroying the insulation on the wires. This is the auxiliary voltage transformer compartment. If the compartment is utilized, the extension rails are the exact same as those on the lower compartments and are also the exact same for trays and circuit breakers. Extension rails are used to facilitate the insertion of the tray into the compartment and allow for complete withdrawal from the cell. On the left, we have the secondary disconnect terminals for secondary wiring. As the tray slides in, these connect. On the top, we see the ground contact system, which removes static charges from the instrument transformer or fuse. Underneath the tray, we have the grounding system. This top compartment is the C compartment. Typically, this compartment is connected to the runbacks by a cable. Now, let's move to the rear of the GMSG skeleton. Starting at the top, you'll see this white lifting angle. This is a connection point for lifting purposes. Pass-through holes for secondary wires along the rear of the skeleton have a black round grommet that stays in the hole to protect wires as they're pulled through. Moving down to the D compartment, here are the bushings that provide a connection point to the primary bus bars. This big, open, rectangular space on the side of the skeleton is where the horizontal bus bars would be to connect one section to another. This is the low voltage compartment, so this is left empty. These upper circuit breaker bushings connect to vertical bus that then connects to the main horizontal bus. And all the way at the bottom, we have the runback connections for the circuit breaker. These angled pieces are for mounting bus supports. This bracket could be used for a space heater. In addition, our partners need to add approximately 28 inches of additional depth to create a cable compartment and to finish the back of the switchgear. We hope you have found this tour of the Siemens GMSG unit beneficial. For further details and information, please refer to our latest catalog, product instruction manuals, or selection and application guide.